All right, if you like the cartoon a few videos ago, the Far Side that was the dog, the man yelling at the dog. Here's another Far Side. Gary Larson loved animals, and it made it very funny. So you can look at that one, enjoy it. All right, the solubility rules are listed there to the right. And first of all, let's define soluble and insoluble. Something is soluble if it dissolves in water. So salt and sugar are both soluble compounds. So we say they are soluble. If something doesn't dissolve in water, let's say for example sand. Sand is what's called insoluble. Does not dissolve in water. And it does not dissolve in water. If we look at the list to the right, it will help us predict whether or not something will dissolve in water or not. Okay, so there we have soluble and insoluble. So let's take a look. Let me erase this. Let's take a look at a reaction. Okay, here we have a reaction between two soluble compounds. So the first, silver nitrate. And we know it's soluble. If something's soluble, it dissolves in water. We give it the AQ symbol. And potassium chloride, which also is soluble in water. So these are two clear liquids that we mix together. And when they're mixed together, they form a solid product. Well, what is the solid product going to be? Well, anytime you have two aqueous compounds as your reactants, you need to determine what the solid compound could be. And we talked about this in the last video, but let me show you a shortcut. The two possibilities for the new compound that is solid are going to be, if you take the cation here and combine it with the anion there, we get AgCl. Now you're going to have to think about charges here when you write the formula. Cl, you can find its charge in the periodic table. It's a -1. Ag, you might not know the charge, but if you look at the charge of NO3, it's a -1. And there's one Ag attached to it. So that means Ag's charge needs to be, if you said +1, you're right. So +1, -1, so it's just AgCl. The other compound that could form would be this cation combining with the other anion. So it could be KNO3. So which of these is our solid? Well, we now use what are called the solubility rules to help us determine. So let's take a look over here. So solubility rule number 1 says most nitrate salts are soluble. In fact, for our purposes, any salt, and a salt is just an ionic compound, a cation and an anion. Any ionic compound that contains nitrate will be soluble. Right away, we know that this product will stay dissolved in water. So this is going to be aqueous. Well, that tells us then that the AgCl must be our solid product. But let's see if we can find a rule on the solubility rules that will show us that it is, in fact, a solid. Most salts of Na+, K+, and NH4 are soluble. Well, that doesn't have any of those. The third rule, most chloride salts are soluble. Notable exceptions are AgCl. Bingo, we have it. So most chloride salts are soluble. An exception is AgCl. So if most are soluble and this is an exception, that means it must be insoluble, and so we would give it the symbol solid. It is the solid. So our reaction would look like this: AgNO3 AQ plus KCl AQ forms AgCl solid plus KNO3 AQ. And we can check to see if it's balanced. It is balanced. So here is our final reaction. All right, let's take a look at this reaction. here we have our two reactants. Both are aqueous, so they're both soluble. What are the two products that could possibly form? So it's going to be Na and NO3 could combine, or this cation with this anion. So let's do the red one. The red one, it could be Na and then NO3. And when you do this, think of charges. This subscript here, these do not, when you rewrite the new possible compounds, you're not bringing those subscripts with you. You're just thinking of the charge. So Na you can find on the periodic table, it's a +1. NO3 is a -1, so that's the formula. And let's do the Pb SO4. So if we look here, there's one Pb and there's two NO3s. NO3 is a -1, so that means this has a total charge of -2, so the Pb must be a +2. So we'll write 2+ here. And the SO4, we can look at the periodic table and see that it's a 2-. They're exactly the same charge, and so charges cancel, and so PbSO4 is our other compound. So now let's look at the solubility rules. Okay, and this is another version of the solubility rules, just another version. And we can see the soluble compounds are all NO3 salts. So right away that tells us that this is soluble. So it will dissolve in water. It will not be our precipitate. And keep in mind, we might not have a precipitate. It's possible to mix two aqueous solutions together and nothing happens. It just stays as a clear liquid. But we can always check to see if we should have a precipitate, and then we'll know what the precipitate is. So let's take a look at our second one, PbSO4. Soluble compounds Na, K+, NH4+, I don't see it there. Soluble compounds Cl-, Br-, I-. Soluble SO4 2- salts. Here's SO4, but there are exceptions, except those containing Ba, Pb+, and Ca2-. And so this is an exception to the solubility, so this must be a solid. And so we now can write our reaction. Let's get rid of, there we go. We now can write our final reaction as NaNO3, sodium nitrate, aqueous and solid lead 2 sulfate. So remember our naming rules. It's not just enough to name this lead sulfate. We have to also, because lead is a transition metal, we would have to give it the Roman numeral 2 because it has a charge of 2. And so we have our final reaction, and whoops, it's not balanced. So we need to balance it before I put the box around it. Got a little bit ahead of myself. Let me erase that. Alright, let's take a look. To balance this, there's two NAs here. There's only one Na here, so I can put a 2 in front of that Na. That balances the NAs. Let's check the SO4s. One SO4 there, one SO4 there, one Pb there, one Pb there, two NO3s, and two NO3s. So now it's balanced. Now we can draw a box around it. That is our completed reaction.